Okay. So last time was discussing the following example, correct? Yeah. Simply,
Yes.
we have the following block diagram, and we need to find a set of transfer function ranging from y over r until z over d. And this is an example for multi-inputs, multi-outputs, in which we have three inputs, which are the R. The first one is the R. The second input is the D. And the third input is the W. And simply we stated that any signal injected into the block diagram is actually an input, correct? So R is in to the block diagram, so it's input. D, it's in to the block diagram, so it's input. W, it's also in to the block diagram, so it's input. And this one is two outputs. تفضلي.
انت ما عمل شير سكرين معنا.
لا عامل شير ديسكتوب انا.
أنا شايفها دكتور.
Yeah. So simply I'm seeing the red line. The red line indicates that I'm sharing my screen. So anyone else cannot see my screen?
خلص هلا طلعت عندي.
Okay, so maybe it's internet connection, huh? I'm sorry for that. Okay, so simply we have let's say two outputs. The first output is the Y, and the second output is the Z. And we stated that any signal out or picked off from the block diagram, it's out. And last time we plotted the signal flow graph, and I think I gave you, let's say, a quiz in order to find the transfer function. And I don't know why most of you could not do anything. Now, in general here, if I need to start finding the transfer function, the first thing I need to define the loops. Correct? Why? Because the loop has no relation with the input output you are discussing. It's the characteristic of the graph. So now let's see. Who will help me with the loops?
دكتور.
تفضل. How many loops?
في 3.
3. So let's see. The first thing I will stand on in node number 2, and I will start to loop. The first loop, can you give it to me?
J5, G5, G4.
So I'm flying in the sky. Okay.
G4 minus H.
Minus H. So this is the first one. So here I will write the loop number 1, L1, which consists of G5, G4, H1, and don't forget about the minus. And this one actually linking node 2, 5, and 6, correct? Yep. Yes. Okay. Now again, you are here. Can I do another loop?
G1, G2, G3,
so
G4,
G1,
minus H.
G2, G3, G4, and minus H. Let's say the 500,000. Huh? So here it will be the loop number 2, which we'll call it L2, which consists of G1, G2, G3, G4, and H1, and don't forget about the minus. And this will link node 2, 3, 4, 5, and 6, correct?
Yes.
Now, another thing, you told me that we have 3 loops, huh? The third one. So where is it?
Minus H.
G2. minus I. Do you see it? The small half million, huh?
Yes.
Okay, so this one, huh? So here I'm having L3, which consists of G2, H2, and don't forget about the minus. And this one will link 3 and 4. Now, in order to find the determinant, I need to specify, are the loop touching or non-touching? Are the loops touching or non-touching? Now,
L3, L1, non-touch.
why? Simply, if I compare, there is no common node in between, correct? Yeah?
Yes.
But if I compare L1 and L2, I can find what? 2 are common, 5 are common, 6 are common. And remember, the sufficient thing is what? For the loop to be touching is to share at least one node. So simply here I can write L1 and L3 are non-touching. Why non-touching? Because they are not sharing any node, huh? Not sharing any node. Good. So I am now in the stage in order to find the determinant, delta. Now, who will help me with that? Delta was equal to what? Do you remember delta was equal to what? Delta was equal 1 minus the summation of all independent loops, yeah, plus the summation of the product of all combination of two non-touching loops, and after that I would have the minus the sum of the product of all combination of 3 non-touching loops. Then I would have plus the summation of a product of all combination of 4 non-touching loops. Now here, how many loops are non-touching? 2, correct?
2.
So simply I have only one combination, which is L1, L3, yes?
Yes.
Yeah. So simply now, can you help me to write delta equal to what? It is 1 minus
Plus
L1 plus L2 plus L3 plus L1, L3, correct? Yeah? Correct. Now, if I need to find the value of the determinant, and remember, the determinant is actually the characteristic equation, correct? Then here I can write delta equal to 1 plus G5 G5 G4 H1 plus G1 G2 G3 G4 H1 plus G2 H2 plus the multiplication of L1 and L2, which is G5 G4 H1 G2 H2, correct? Yeah. Yes.
Yes, doctor.
Good. So now, if I need to find the transfer function, the first transfer function, which is the main one, let's say, the relation between the actual input and the output we are interested in, which is the y over r. I need to find this one. So now the first thing here, I need to determine the paths. I will return back to the signal flow graph. And now I need to highlight how many paths I have from R to Y. So ask yourself, if you are standing on R and you need to go toward Y, how many ways, how many paths you have?
2.
2. The first one.
G5, G4.
So the first one is this one, G1, G2, okay, G5, huh? G5 and G4?
Yes.
The second one?
G1, G2, G3, G4.
G1, G2, G3, G4, correct? Yeah, it's easy, it's a piece of cake actually. So I don't know why you say that the quiz was difficult. So here I'm having 2 paths. The first one P1, and you started with G5, G4 it was, huh? Correct? It was G4? Yeah, G4.
Yes.
G4, and this will link node 1, 2, and 6, correct? Yeah. 1, 2, 5, and 6. So here I'm having also 5. And we have another one, which is the P2, which is the main one, starting from G1, G2, G3, G4, and it's link all the nodes, I think. 1, 2, 3, 4, 5, and 6. Now, is the path touching the loops? Is the paths P1, let's say, touch all the loops? Now
No.
let's see. No or yes?
No, في
No.
اللوب الصغيرة.
Yeah. You see it? Yeah.
Yes.
So this path touch all the loops except the
G2 ما H2.
the small 500,000, let's say. Huh? Yeah.
Yes.
Yes. So simply, and this loop, I think it was L3. Huh? It was L3. So if it was L3, this means that here I can write delta 1, which will equal to delta such that any loop touch P1 go to 0. So simply this will equal to, so only L3 does not touch the path, correct? So this will equal 1 minus L3. Yeah.
Yes.
What about the second cofactor, delta 2, equal to what?
1.
Equal to 1,
One.
huh? Yeah,
Yes.
why? Because simply if I return back to the single flow graph and this one, huh? It touch all the loops, correct? So this path touch all the loops. So simply this means that the cofactor is equal to 1, huh? Yes. Now, can you give me y over r equal to what? Let me choose. Aus.
ويس معك دكتور.
أويس، يلا يا أويس.
P1 دلتا 1
So P1 delta 1
بلس P2 دلتا 2
uh-huh.
أو أوفر دلتا
Yeah. So it's piece of cake, correct? Yes. Good. Now, can you help me with the second transfer function, which is, let's say, y over d? Can you help me with that? I need now to find y over d equal to what? What I need to specify here. Should I return back and find the loops? Should I return back and calculate the determinant?
No.
delta? No.
The
Why?
same.
The loops will never change, correct? Yes.
Yes.
So simply only I need to what? To locate the path, correct? And if I change the path, the cofactor will change. Now, ask yourself, you are here. Yeah? And you need to go to where? To the Y. How many ways you have?
One way.
One way, which is
1, G2, G3, G4.
yeah, thank you. This path touch all the loops?
Yes.
Yes.
Yes. Simply here I'm having only one path, P1, which actually was starting from where? From G2, huh? G2,
Yes.
G3, G4, and this will link node, I think 3 it was, 3, 4, 5, and 6, yeah? So simply this will touch all the loops, so delta 1 is equal to 1. So now, can you give me Y over D equal to what?
B1 delta 1 over delta.
Yeah. So if only I'm interested to find this one, I will stop here. If I need to calculate later on, if I need to find the transfer function in S domain, simply I need to substitute, correct? Although now we are what? We are using, let's say, a known transfer function, correct? G1 for me is a function of S. But which function? Until now, I'm not specifying it, correct? So is it difficult now? Is it difficult? Yeah.
No.
So
No.
simply you should do, let's say the other transfer function. Yes.
Yes.
Good. Okay. So let's give you another example. Assume there are 3 non-touching loops. L1, L2, and L3. Find the characteristic equation. So simply here, what I need to find?
Delta.
Delta.
Delta, yeah, thank you. So here, actually, I need to find delta is equal to what? Yeah, correct? Okay. So who can help me with that? And let's see, I will choose Khalid Akram. Khalid. 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 Khalid not here. Khalid. Help me with that. Yeah. I need to find the delta in a system where only I'm having 3 loops and those loops are non-touched. Yeah, so delta equal to
1
delta equal to 1 minus
L1
L1
L2 L3
plus L2 plus L3 or multiply by or L1 L2 L3.
لا
So it's correct this one?
yes.
After that or finish plus
L1 L2
L1 L2
plus L2 L3
L2 L3
plus L1 L3
L1 L3.
minus
Should I stop? Should I stop or continue?
لا minus
Minus. Yeah.
L1 L2 L3.
Yeah, L1 L2 L3. Thank you. So simply this one actually is 1 minus the summation of all the loops. This one, correct? Yeah. Those are what? The sum of the product of all combination of two non-touching loops, and finally this one actually is what? The sum of the product of all combination of three non-touching, correct? So this is 3 non-touching. So simply this means that finding the transfer function using Mason is very simple, yes? Yeah.
Yes.
Good. So let's try this example before finishing Mason. Assume I'm having the following block diagram. This is R of S. Let's assume this is the Y of S. And let's assume here I'm having D of S. And this is G1. Let's assume this is G2. This is G3. And this is the G4. And I need to find Y of S. So simply find Y of S equal to what? So who can help me with that? Okay. Hisham? Hisham? Not here? Hisham?
نعم دكتور.
So can you help me with that?
بنحولها الصيغة
Signal flow graph. Signal flow graph. We call it SFG, huh? Signal flow graph. Okay. So how many nodes we have here? So simply how many nodes we have?
1 2 3 4 5.
5. So simply you stated that here is a node. Yeah.
Yes.
Here is a node. Yeah.
Node.
Here is a node. Yeah.
Node.
And here is a node, correct?
عند الواي نود وعند الدي دكتور كمان.
And here is the node.
وعند الواي كمان.
And this one is the same, by the way, because in the end of the day, the summation of the signal is equal to the y.
Yes.
Yeah. Yeah. Yes. So simple. Okay. So this means that here I'm having the 1, the 2, the 3, and the 4. So I will start from the R of S, and I will plot from here to here
J1.
branch with a gain equal to J1, and from here to here a branch with a gain equal to what?
1.
Yeah, thank you. With a gain equal to 1, and this signal is D of S. And from here to here a branch with a gain equal to what?
J2.
Then I'm having one from here to here, correct?
Node. Yes.
With what? With
G3.
G3. Then
node 4.
Node 4. Just a minute. Let's number it for you. So this is 1.
3.
This is 2. This is 3. And
3.
this is 4. Yeah?
Yes. من node 2 ل 3.
No. No, look to the direction of the arrow. So here you have two choices. The first one is to make here a node. Yeah? In this case, the first one, the branch is G3, then 1. Or simply you are saying that the path or the gains from R to Y is what? Is actually
G3, G4.
G4, correct? Yeah?
Correct. Yeah.
They are the same. Yeah? So this is valid. Or if someone say, no, I need to stick with this one. This is more easy for me, maybe for figuring out everything. Yeah. So in this case, this will be the R of the S. This will be the first branch with again G1. This will be the second branch connecting D to this node. And after that, here I'm having G2. Then I'm having connection between R and this node with G3. Then here I'm having connection with one unity. And here I'm having a connection with what?
G4.
With G4 connection, correct? Yeah.
Correct.
طب دكتور إذا حطيت الجي 3 والجي 4 مع بعض مش هذا ممكن يخرب عدد اللوبس أو عدد الباثs أو كيف ممكن يطلعوا إذا سويت الترانسفير فانكشن؟
Now let's see. Let's find the transfer function in the two ways. Yeah. Yeah. Do you know what I did here? I did a picking of the point. Huh? So simply what I did here, I pick off this point and put it here, correct? Yes.
مظبوط.
So simply I did not change anything. I only rearrange the equation. So I'm mixing the block diagram prediction with the single for graph, correct?
Correct.
So if this is the case, this means that if I'm using the first signal flow graph or the second signal flow graph, it will never change. Yes or no?
Yes.
Yes.
Yeah, so let's try it. Let's try it. So you prefer to start with the classical one in which you have almost the signal flow graph capturing the same shape of the block diagram. This one capture almost the same shape, correct? Yeah. This is the one. So here, the loops. L, how many loops I'm having?
0.
0 loop. Are you sure?
دكتور ما في طريق بسمح لي أمشي مع الأروز، بصير أمشي عكس الأروز.
Good.
في واحد دكتور.
Where?
من الأولى.
من الأولى. Okay, let's number.
Okay, لا ما فيش.
So this is the 1, this is the 2, this is the 3, this is the 4, and this is the 5. Yeah. Good. So if there is no loops, simply here let's write no loops. The term is equal to what?
1.
Yes. So no loops. In this case, the determinant equal to 1. And if the determinant equal to 1, this means that any codeterminant should equal to 1, correct?
Yes.
So only I need to find the paths, yes? Yeah?
Yes.
Okay. Now, before finding the paths, for this one, do I have loops?
No.
No. So the same, huh? For this one, if I'm using this one here, still I'm having the delta equal to 1 and delta I is equal to 1, correct? Okay. Now, what I need here to find y of s. Yeah. So y of s is a combination of two transfer functions, correct? Or let's say y is a combination of two responses. One is due to the r, and the second one is due to what? The d. Yeah.
Yes.
Okay. So simply y actually is t1 of s, let's say, multiplied by r of s plus t2 of s multiplied by d of s. So I need to find two transfer functions. So who will help me to find the first one? t1 of s, which actually
G3.
y over r when d is equal to 0. So here I need only to find the path, correct? How many ways I can go from r to y?
3.
2 ways.
Two ways. Huh? The first one,
G1, G2.
G1, G2. The second one,
G3, G4.
G3, G4. The third one,
G3, G2.
and P3 is actually equal to G3, G2. Do you see it?
Yes.
Yes, بس دكتور أنت كاتب path to G3, G3.
Okay, my mistake. I'm sorry about that. So this is G3 plus 1. So this is actually G4, huh? Yeah, thank you. G4. So simply delta 1 equal to what?
1.
1. And delta 2 equal to what?
1.
And delta 3 equal to what?
1.
1, 1, 1. So now we can find what? T1, huh? Yes? What about T2?
G2.
T2. So you are standing on D and you need to go toward Y. How many ways I can do that?
Just 1.
Just
1.
1.
1.
Yeah, thank you, 1. So simply here I'm having a B D1 and this will equal G2 and delta of D1 is equal to what? 1. So now who can give me Y equal to 1? Who can help me to write Y? So now Y of S will equal T1. Do you remember T1 was what? P1 plus P2 plus B3 over delta, which is the 1, all multiplied by what? R of S plus T2, which is G2, multiplied by D of S, correct? So if I substitute, Y of S will equal to G1, G2 plus G3, G4 plus G3, G2 all multiplied by R of S plus G2 D of S. Yes?
Yes.
Yeah? Okay.
Yes.
Now, if I need to find Y of T, in general, I'm interested in the response in the time domain. What I should do What I should do?
Laplace
So,
inverse.
now I need to evaluate the Laplace inverse of what? Of y of s. Yeah. But in order to do so, I must specify G1 equal to what? G2 equal to what? G3 equal to what? G4 equal to what? And so on. Yes? Yep. And also what I need to specify? I need to specify the input, correct? Yes? Yeah? Because in the end of the day, the response is due to what? Is due to the input. Yes? And remember, in general, we are interested in what? Either in step input, impulse input, or sinusoidal input, or ramp input, let's say, or parabolic input. Later on, we will highlight the parabolic and the ramp input. But in this stage, we are interested in the step input, in which R of S is equal A over S. If unit step, it will equal 1 over S. If impulse, then R of S is equal to 1. And the same thing for the D. Yeah, so I must specify the input in order to find what? In order to find y of t. Yes. Good. And for that, let's take the following example. Let's assume this is R of S, negative feedback, and this is Y of S. Alpha and beta are positive constant. Yeah, and this is what? 1 over S integrator, huh? This is what? 1 over S here, and here I'm having 1 over S. And what I need to find the unit step response. Find the unit step response. Yeah. Who can help me with that?
دكتور أنا
Yeah, تفضل.
أول إشي بدنا نحولها للإس في إس إف جي.
Okay, signal flow graph. Okay, I will go with you and I will convert it. How many signal you need?
4 nodes.
So here 1, yeah. Here 1.
هون واحدة 5 يعني.
Here 1. Here 1. And here 1, yeah. 1, 2, 3, 4, and 5. Yep. Okay. So let's go with 5 nodes. And here I will 1, 2, 3, 4, and 5. The first one is R of S, connecting with node number 2. So 1, 2, 3, 4, and 5. So this is the 1 and this is the 2. Then from
بعديها هون بدنا نحط 1 1 2 الرقم 1. وبرضه هون 1. هون 1 على S.
And 1. Okay. Here
1 over S.
Over S. And here
وهون 1 over S.
1 over S. And this is the 2, this is the 3, and this is the I'm having 2. The 3, and this is the 4, and this is the 5. Then, and this will be the y.
من 5 ل 2 سالب ألفا minus ألفا.
Yes. So minus alpha. And
ومن 4 ل 3 minus beta.
Minus beta. Good. Thank you. So can you continue? So
yes.
The first thing, what you need to find the loops, huh? L, how many loops am I?
2 loops.
Okay. 2
دكتور
loops.
بس هاي بيتا ولا ماينس بيتا؟
Minus beta. Thank you. It should be minus beta. Thanks. It's minus, huh? Thank you. So minus beta. So the first loop, L1, which is
1 هسه من هي من ل 5 وراح نرجع يعني 1
2 3 4 5 and return back, correct? Yes. Good. So this means that it's 1 multiply 1 over s multiply by 1 over s multiply by minus alpha, correct?
Correct.
So this will equal minus alpha over s square, yes? And this connecting 2, 3, 4, and 5, yeah?
Yeah.
The second loop, L2.
اللي هي بين 3 و 4 يعني 1 over s multiply by minus beta.
This one, correct? 3 and 4, yes, thank you. So this one is minus beta over s, which connecting 3 and 4, yeah? Are the loop touching or non-touching?
Touching.
So the loops are touching, correct? So L1 and L2 are touching. Why touching?
ملتقيات باثنين بلوبين اللي هم بنودين 3 و4.
Yeah, thank you. So they are share not 1, 2 nodes, correct? 2 nodes. Okay. So can you give me the determinant now equal to what?
Yes. 1 minus L مجموعهم L.
Okay, minus L1 plus
L2 plus
yeah
L1 ضرب L2.
Why? Because the loops are those touching, man, not non-touching. So I will stop here, huh? The loops L1 are touching, so I will stop here. The other terms are for what? For non-touching, huh? So this will equal to what? Substitute 1 plus alpha over s square plus beta over s, correct? Yes?
Yes.
Okay. Now, who will help me with the paths? Thank you.
Welcome.
Another one? Who will volunteer?
Yes, Doctor.
تفضلي. So I need the paths. How many ways I can go from R to Y in the same direction of the arrow without enclosing any node more than once?
One path.
Only one path, which is
1 over s multiplied by 1 over s.
So 1 over s square, and this path link all the nodes 1, 2, 3, 4, and 5, which means that the codeterminant is equal to 1. Yes? Why? Because this path touch all the loops. Yes?
Yes.
Good. So can you give me now the transfer function equal to what? Can the y over r equal to what?
P1.
P1, which is okay, P1 delta 1
delta 1. Yes.
Now you should substitute, because yes. I need to find what the response, correct? P1 equal to what?
1 over s squared.
S square multiplied by 1 over
1 over 1 minus
1 plus
1 plus
alpha.
Alpha over s squared plus beta over s.
Okay, beta theta over s. Now, do you remember? I must write it in terms of n over d, where n and d are polynomial in s. Yes? Correct? So I should multiply by s square here. And I should multiply here by s square, correct? I need what? I need to simplify the transfer function, correct? I need to write it in terms of what? Of n over d, where n and d are what? Are polynomial. Are polynomial in us. So if this is the case, y over r equal to what? Can you multiply here?
1
over
s square plus 1 plus alpha
plus okay, beta s.
Okay, plus alpha.
Yeah. So now if I need to find let's say y of t, the first thing I must specify beta, alpha, and r. Yes? Yeah. And for that, let's assume that alpha is equal to 6 and beta is equal to the 5. Yeah. And I need to find the unit step response. So find the unit step response. So simply I'm giving you now what? The values. I'm giving you now the values of alpha and beta. So what I need to substitute. Yeah. So if I substitute, now I'm having what? I'm having y over r is equal 1 over s square, yeah, plus 5s plus 6, correct? Yeah?
Correct.
So simply this implies that y is equal 1 over s multiplied by s square plus 5s plus 6, correct?
Yes.
Why? Because I'm assuming that the input is
One
what?
over s.
Is unit step, huh?
Oh, yeah.
This means that r of s is equal to what? 1 over s. Yes? And we know that y is equal g, or let's say here t, or I don't have g here, so I can use g. G multiplied by r, correct? G of s multiplied by r of s. Now, I need to find what? Laplace inverse for this one, correct? So I need to find y of t, which actually Laplace inverse of y of s. And how I can do that?
دكتور بدنا نطلع الروتس للمقام.
So simply the idea behind Laplace inverse actually is not to do the complex integration. The idea behind Laplace inverse is to simplify the transfer function. I can write it in a form. I can locate it in the table. For example, if I'm having here f of t, here if I'm having f of s. I know if I'm having 1 over s, then this will be what? U of t, correct? If I'm having here 1, this will be what? Delta of t. Yeah? If I'm having here, for example, 1 over s plus alpha, this is actually what? Exponential minus alpha t, correct? If I'm having omega square over s square plus omega square, what I'm having, for example?
Sine?
The sine. If I'm having, let's say, if I'm having 1 over s minus alpha, what I'm having? here minus. So this would be the exponential of alpha t. Yeah.
Yes.
So the idea is to do something called the partial fraction expansion. Do you remember the partial fraction expansion?
Yes, Doctor.
Yeah, the partial fraction expansion. Now, so simply here, if I need to simplify it, y 1 over, I would say that this is s, and this is the second equation. I can find the roots, correct? The root is minus b plus minus the square root of b square minus 4ac over 2a. So simply, if I do the math, this will be s plus 3 multiplied by s plus 2, correct? Yeah?
Yes.
Yeah. So simply, it's s squared 5s plus 6. So now, here what I'm having? I'm having y of s, which will equal n of s over d of s. And I'm having the degree of n of s is less than the degree of d of s. Yeah, the degree of n of s is equal to what? 1. The degree of the d of s here is equal to what? 3, correct? And there's no common factor. There is no common factor. So in this case, I can do the partial fraction expansion, and this case is what? The root of d of s are distinct, correct? So in this case, d of s equal to 0 has distinct root. Yeah, which is mean that none repeated roots. So in this case, y will equal how many roots I'm having?
3 roots.
Yeah, 3 roots. So this will be the summation from I equal to 1 up to n, let's say, ki over s minus, or let's say plus, okay, plus pi. Yeah, where pi is what? S equal minus pi is the root, and k is the resultant of the partial fraction expansion. So in this case, how many roots I'm having? 3. So y will equal k1 over s, yeah, p equal to 0, yeah. The second one plus k2 over what? S plus 3, the second one. The third one is what? K3 over S plus 2. So here I'm having P1 equal to 0, P2 equal to, if I use this P, this will be the minus. Okay, let's, in order to make it, to respect the math, huh? Just only to respect the math, here I will say it's minus. In this case, S will equal to what? Plus P. Yeah, let's fix it. Only to respect the math, huh? S minus Pi. So here, P1 equal to what? Minus 3, correct? Yes. P3 equal to what? The third root. The third root equal to what?
Minus 2.
Minus
2.
So if you plug this one here, it will be K1 over S. This will be S minus 3, and this will be S minus 2, correct? Now, how to find K1, K2, K3 in this case? In the case of non-repeated root, the thing is very simple. The thing is very simple. So Ki will equal S minus Pi multiplied by Y of S evaluated at the root, S equal to Pi. Yeah. So the first one, if I need to find K1. So if I need to find K1, K1 equal S minus B1, S, correct? Multiplied by Y of S, it was 1 over S square, or if you need to write it in the expand form, it will be also okay. It was S plus 2 multiplied by S plus 3, evaluated at which root? At S equal to 0. So this one, according to the Pacman theory, will eat this one, and I will end up with what? Evaluate. If I evaluate the math, I will end up with 1 over 6, correct? 1 over 6, correct? Yes?
Yes.
Yes.
Okay, who can help me with K2? K2, it was connected with S minus 3. So K2 equal the root S plus 3 multiplied by Y of S 1 over S plus 2 S plus 3 and I will evaluate at S equal minus 3. So according to Pacman theory, this one would eat this one, and I will end up with what?
Minus 1 over 3.
1 over?
Minus
1
3.
over 3.
Yeah, minus 3. This will be the minus 1, and this will be what? The minus 3, so 1 over 3, not minus. Correct? Yes? The
Yes.
resultant here is
Yes.
minus 1. The resultant
Minus
here
1.
is minus 3. So if I multiply, this will be equal to what? 1 over 3, not minus 1 over 3. Yeah? Now, the last one, K3, equal to what? The root I'm evaluating is S plus 2, correct? Multiplied by the function itself, S plus 2, S plus 3, and I'm evaluating at the root, which is S equal to minus 2. So according to the Pacman theory, this one will eat this one, and I will end up with what?
Minus 1 over 2.
Minus 1 over 2. Yeah, minus 1 over 2. Why? Here is minus 2, and here the resultant is 1. So it's minus 2. So now I can write, Y of S. Now I can write here, Y of S will equal 1 over 6 multiplied by 1 over S, yeah, plus 1 over 3 multiplied by 1 over S plus 3 minus 1 over 2 multiplied by 1 over S plus 2, correct? Yes?
Yes.
Okay. Now, look to those terms. Can I locate it in the table? Do I know, let's say, the inverse Laplace for those?
Yes.
Yeah,
Yes.
the first one is the unit step. The second one is exponential of 3t minus 3t. And the third one is what? Is exponential of minus 2t, yeah? So now I can write y of t will equal 1 over 6 plus 1 over 3 exponential of minus 3t minus 1 over 2 exponential of minus 2t minus 2t, and all multiplied by u of t to ensure that the function is starting from what? From the 0. Yes? Correct?
Yes.
Okay.
Yes.
Now, see, This actually the steady state response, and this actually the transient response, correct?
Yes.
Yes. Why we call this one steady state response? Because this one the response will still down after t go to infinity, and this terms will vanish, correct? So this actually is what we call the steady state response. And this actually what we call the transient response.
كيف عرف الدكتور انه هاي steady وهاي transient كمان مرة بضوء؟
Okay. What the meaning of the steady state and what the meaning of the transient response? Now the steady state response is the value of the function at t go to infinity, correct? Or after settling time. Yes? So if I substitute here t go to infinity, this term will go to 0, this term will go to 0, correct? Yes?
Yes.
And only I'm having this one, yeah? Another thing, this term is coming from where? From the input or from the system itself? This term. If I remember, this term was coming due to the input, correct? Yeah, this one. Yeah. So this is in the mathematics what we call it what? The forced function. Yeah. Or particular response. The forced solution or the particular response. And those are what we call the homogeneous response or the natural response, which are the transient response. Yeah. Yep. Good. So now let's see what the relation between this value and the transfer function evaluated at s equal to 0. Do you remember g of s was equal to what? It was equal 1 over s squared plus, it was I think 5s plus 6, yeah? Yes?
دكتور هيك كانت.
Tell me to find g of s at s equal to 0 is equal to what?
1/6.
1/6, and this what we call it the DC gain. So simply the value of the transfer function at s equal to 0 is specifying the gain. So here the system is attenuating the input or amplifying the input or maintaining the input.
Attenuating.
Attenuating. Why? Because the gain is less than 1, correct?
Yes.
Yes, the gain is less than 1. Yeah, good. So this is what we call the DC gain. Yeah, and this is very important. Now, if I'm telling you, give me the value of the error, E of t equal to what? Or let's say E steady state. Or E of t equal to what? The error.
5/6.
The error, this is one time. So I need a function of time. That was what? That was the steady state value, huh? So here, do you remember E of t was E of t? No, okay, E of s is equal to what? E of s is equal, according to the tracking error, whatever I'm having, is R of s minus Y of s. This is what we call the tracking error. So simply, E of t will equal what? R of t minus Y of, yeah? And this will equal to what? 1 minus Y of t, and already we have Y of t, yeah? Yes? Correct?
Yes.
Now, E steady state equal to what? Remember, E steady state is what? What's the meaning of the steady state value? the limit when t go to infinity of e of s, correct? Oh, of e of t. Of e of t. Yeah. So simply here, so e steady state is equal the limit when t go to infinity of e of t. Now this one equal to what? It was 1 minus, or let's say the limit when t go to infinity of 1 minus 1 over 6 plus 1 over 3, huh?
Yes.
1 over 3 exponential minus 3t minus 1 over 2 exponential minus 2t u of t. And simply if I evaluate, it will equal 1 minus 1 over 6, and this equal to what? 5 over 6. Correct?
Yes.
Good. Now, I can find E steady state using the final value theorem of Laplace. E steady state using the final value theorem of Laplace will equal the limit when s go to 0 of s e of s. Good. Now, E of s equal to what? If I need to evaluate the steady state error using E of s, I must find E of s. E of s equal to what?
R minus y.
Yeah, so R of s minus y of s. Yeah. Just a minute. I need to drink water. Good. I'm back. Okay. Where is it? On. Yep. All right. Okay. This one. Yeah. Now, if I simplify this one as 1 minus y over r multiplied by r, this correct? I'm taking common factor what?
Oh.
I'm taking r as a common factor, yeah? So this will equal to what? 1 minus y over r was what? 1 over s squared plus 5s plus 6 multiplied by the r. This equal to what? If I simplify s squared plus 5s plus 6, here I will have what? S squared plus 5s plus 6 minus 1, correct? All multiplied by what? By r. So in the end of the day, E of s equal to what? Equal s squared plus 5s plus 5 over s squared plus 5s plus 6, and let's substitute the input, which is 1 over s. So here I'm having s. Now, according to the 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 final value problem. Is this state will equal to what? The limit when s go to 0, s e of s, and if I evaluate this will equal to what?
5/6.
Yeah, 5/6, which is correct. Yeah. But simply, you should understand that the final value problem must be used if and only if the function that I'm evaluating has no positive root or no repeated j omega roots. So here I will write for you the final value theorem of Laplace, which stated that y steady state is equal the limit when s go to 0 of s y of s, and this actually is identical to the limit when t go to the infinity of y of t is valid only if and only if, let's say, if this read if and only if, this we read it as if and only if, this one, y of s has no positive real part roots nor repeated roots at the origin. So simply only I'm allowing one root at the origin y because of the unit step. The unit step is 1/s, correct? Yeah. Or simply if you need to link it with the stability, I can say that I can use the final value theorem if the transfer function is stable. So simply this will be more interesting, that if I'm relating the final value theorem to the transfer function, and we know that the transfer function g of s is what? Is y/r. Now, if this one is stable, then we can use the final value theorem of Laplace. So you can use the final value theorem of Laplace. Good. Do you need example for that? Assume that y of s is equal 1/s minus 1. Who can find y steady state equal to what? Who can find y steady state equal to what? Equal to what?
-1.
So you are using what? The limit when s go to 0, s y of s, correct? Yes. And if you are doing the math, this is equal to what? -1. Yes. Correct?
Yes.
Unfortunately, this is not correct. Why? Now let's see. In general, y steady state is the limit when t go to infinity of y of t. And if I do here the partial fraction expansion, this will be what? S will eat the s and evaluate, so minus 1 over s, then minus 1 over s minus 1. So if I do the math, this will be the minus 1 minus exponential of t. Yeah, u of t. And I need to evaluate at t go to infinity. This equal to what?
Infinity.
Infinity. So simply now, the final value theorem of Laplace is not valid. Why not valid? Because the system has a root which is located in the right hand side. So if I need to project the first one here, y of s has no positive root, simply y of s has a positive root, so I cannot use it. Or simply if I need to project it as a transfer function, and this will be more easy, y over r is my transfer function, which equal 1 over s minus 1, correct? Yeah, as transfer function. And if I'm plotting the s domain, then I'm having a root. Where's the root? On the right half plane. So the system is unstable. What's the meaning of the system unstable? The system is unstable if there's a bounded input, then the response become unbound. So here I'm injecting what? A step, but the response is what? Is diverging. Yeah. So it will go to the infinity as t go to infinity. So in this case, I cannot use what? I cannot use the final value problem. So the final value problem, I can use it if the system is stable. And the meaning of the system is stable is what? All the root must be located where? In the left half plane. Good. Any question?
دكتور كيف نعرف إن السيستم unstable غير البوزيتيف روت؟ في طريقة تانية بسرعة نعرفها؟
Later on, when we check the stability, we can study something called the Routh-Hurwitz criterion. Yeah, the Routh-Hurwitz criterion. Now, from this, if I'm having the response, let's say y of t equal 3 plus exponential minus 3t sine 5t. Okay. Now this one, stable or unstable? Now simply you say that if the system has a final value, then the system is stable, correct? Yes?
It's stable.
It's stable. Why? Because the final value is actually 3. Yeah? Yes?
Yes. Yeah.
Yep. Okay. This term will go to 0. So simply if I need to plot this one, the final value will be 3, will be something like this. Well, this one is 3. And this is the time, and this is y of t. So if I'm having a function in time, it's very easy to see the system bounded or not by evaluating the limit. Yeah. But in general, I don't have system in time domain. In general, what I'm having a system in S domain, correct? So in this case, what I'm having y over r, which is the transfer function. And let's assume I will have 3 over, let's say, here s square plus 25 multiplied by s plus 3. Yeah. Yes. Or let's make it more. Let's make it s square plus real for s plus square, let's say 4 and 3 real square, so 2 square is 4 312, something like that. Let's see. Minus. Oh yeah, okay. So let's assume this one. Huh? Now, is this one stable or unstable? For this one to know if the system is stable or unstable, I need to find the roots. Huh? I need to evaluate s squared plus 4s plus 12 equal to what? Now, if I evaluate according to the closed form solution minus b plus minus the square root of b squared minus 4ac over 2a, this will equal to what? This will equal minus 2 plus minus j3, correct? Yeah? Because if I need to evaluate, this will be s squared plus 2 of the real, which is the 4, plus the magnitude square, which is the 4 plus the 9. So this will be the 13. Huh? Yeah. So this system, the roots for this system, s1, 2 are minus 2 plus minus j3. The real part, negative or positive?
Negative.
The real part. Negative or positive? Negative. So the system is what? The system is stable. Huh? Yes. Anyone?
Yes, yes.
Okay. So do you have any question before finishing the lecture?
لا دكتور يعطيك العافية.
Okay. Okay. So يعطيك العافية.
الله يعافيك.
عافيك دكتور.